Hello. This video is about confidence intervals when sigma is unknown. So up until now, every time we wanted to calculate a confidence interval, and we knew that the sample comes from a normal distribution, or we had a sample size of more than 30, we just assumed that it becomes more and more normally distributed, the sampling distribution, and we were able to find our confidence interval by using the critical z-value. However, most of the time we do not know our sigma. Sigma is unknown to us. And more than often, when you use statistical methods, what you're going to do, you're going to use the standard deviation of the sample. So S is the standard deviation of the sample. And I'll remind you that X bar was the mean of that sample, okay? Mean of sample. Okay, so when we do not know sigma, we're going to use that S in place of the sigma. And if we would have continued using z distribution, we would end up missing, if let's say that I wanted to find a 95% confidence interval when I didn't know the sigma, okay, sigma unknown, and I have continued to use, if I used my z critical value, what would happen is that more than 5% of my confidence intervals would miss my parameter, okay? So if I am trying to estimate my mean, I would have, if I would made 100 of these confidence, if I would have made 100 of these confidence intervals, I would have more than five confidence intervals that miss my parameter of the population. And that is not something that we want to happen. So we are looking for a different way of being able to find the margin of error. If z critical value does not work for us, there must be some kind of other way that we can find these margins of error. So if you remember, these arms that were stretching out from our point estimate were our margin of error. And the way to do that is by introducing this new distribution. And we're going to call that a t distribution. Now, this t distribution is very similar in a lot of ways to the normal distribution. It is also bell-shaped. It's symmetric about the mean. The mean and the median and the mode are all going to be in the same place because it's going to be unimodal. And the curve is going to be approaching the x-axis but not touching them. So it is going to be very similar to a normal distribution, and this is our t distribution. The only thing is with a t distribution compared to a normal distribution, okay, is going to be that it's going to have these fatter tails, okay? So our normal distribution, this is our normal or our z distribution, it has really tapers off and comes very close to the x-axis. The t distribution kind of depends on the number of degrees of freedom, right? Here's another term that we introduced earlier, degrees of freedom, df. And degrees of freedom are going to be actually one less than the number of things in our sample, okay? So the greater the degrees of freedom, okay, the closer we're going to come to a normal distribution, okay? The thinner these tails will become, okay? And eventually in the infinite, we're actually going to be approaching to the z distribution. In the next video, we're going to look at a T-chart, which you should have either in the back of the book or the insert from your book. See you then.